R is the gas constant, which is 0.082 liter atmospheres per mole degree. This is the same gas constant as in the ideal gas equation, Chem1A. And then T is the temperature. In degrees Kelvin. Okay, so let's take a look at the information given from this problem. So let's see. We're given the volume 10.0 milliliters. So is there a volume that we have to use in this equation?
10 mils.
Yeah, but where in the equation do we use it? So we'll use that for in the liters of solution. We're given the mass 0.225 grams of protein. So how will we use that mass in this osmotic pressure equation? Yeah, so note that the moles of solid U, that's going to equal the mass divided by the, what was it? Yeah, molar mass. Okay, so this is where that mass comes in. We're also given the pressure 0.257 atmospheres. What does that pressure refer to? So that pressure refers to the osmotic pressure. Okay, so we know what this value is. That's 0.257. Find temperature is 25 degrees. Where are we going to use temperature in this equation? Yeah, T. Okay, so we know what the osmotic pressure is. We know what, do we know what I is? Okay, because it says here that the protein has been isolated with the formula N20P. This means that there's 20 sodium ions associated with a negatively charged protein, P20 minus. So does that tell us about the I value? Okay, so that means that this dissociates into 20 sodium ions and a big protein molecule which has a charge of -20. So based on this, can we figure what the I value is? George? Yeah, 21. So if you add these numbers from here, there's 21 particles in solution, so I equals 29. Now we don't know what the molarity is, but we do know what the mass and the volume of solution are. We don't know what the molar mass is. We know what R is, 0.082. We know what T is. So based on this, can you calculate the molar mass? Okay, so what I'd like you to do is calculate the molar mass. Once you do your calculation, compare your answer to the person sitting next to you. See if you get the same answer. If you don't get the same answer, try to figure out why there was a difference.
We're trying to find
Okay, does someone have an answer for the molar mass of this protein? No one has an answer? Would someone like to come to the chalkboard and be on YouTube showing off their solution to this problem? I thought all you guys wanted to be rich and famous. This could be your start. Okay, so let's plug in our numbers. So we have, here we have, let's see, the pressure is 0.257 atmospheres. And that's equal to I value, which is equal to 21. Now for the molarity, we have the mass, which is 0.225 grams. Okay, so that's 0.225 grams divided by the molar mass, which we don't know. And then divide that by the volume of the solution, which is what was it, George? Okay, 10 milliliters is 0.010 liters. And then the R value is 0.082. And then the temperature is 25 degrees, but we need to convert that to degrees Kelvin. So that's going to be 298 Kelvin. So we want to solve for molar mass. So if we do some rearranging here, let's see, we have, let's put all the, let's see, we have 0.257 times 0.010 see, divided by 21, divided by 0.082, divided by 298, and let's see, we have the, let's see, 0.225, and that's equal to 1 over the molar mass. Did I do my math here correctly? Then when you solve for molar mass, then you see, take this number, take the reciprocal of it, 1 over it, and that should give you the molar mass. Okay, so what'd you get for your answer?
You don't want to say no.
Now, as a review, what's a protein?
Bunch of
Yeah, it's a molecule. Okay. What kind of molecule is it? So it's we know that a protein is a type of biological molecule, and we know that a protein is the